Hi there, my name is Adam Compton, and today we're going to be starting on the first part of a programming series of videos, or videos on programming, I should say. This is a series that has evolved over time. I initially wanted to do a video series on programming for pen testers, predominantly focusing on Python and a few other select languages. But while I was working that up, it dawned on me, or came to my attention, that not everybody is fluent in Python. So I started working on a prequel set of slides on Python programming in general. And same thing happened again, where maybe not everybody who's going to be watching this or wants to get into this has much programming background at all, which brought me to this set of slides here. So we're going to be starting out this entire grand series of multiple presentations, some with intro to programming, some with Python programming, some with Python programming for pen testers. So first out, we're going to be going into intro to programming. This is part one of possibly 2 to 3 parts. Haven't got all those worked out yet, but let's go ahead and jump into it here. First of all, why would someone want to learn a programming language? Why would you go through all the work and effort to do this? Well, the bottom one down there is the most appropriate answer for me is why not? It doesn't take anything other than your time and effort to go into this. Many of these resources, whether it's a video series, whether it's a free online PDF, they're just that, they're free. You can get access to them, you can borrow books from somebody, things of that nature, and it's only going to cost you your time to go through it. But assuming you did go through the effort and the time to learn a language, there are a number of other things that you can benefit from this. One, by thinking about how to attack a problem with a programming language, to solve an issue, to come up with an algorithm to solve a particular issue. It helps you start thinking about problem solving and problem solving techniques. And the more you practice and the more you think about something like that, the better you get at it, the faster you get at it. So it's going to help with general problem solving skills overall. Second, it helps you understand how some of the tools or technologies that you're already using might work. The people who develop those are programmers or hardware people, which think a lot like programmers at times as well. So it's just one of these things where the more you understand how the underlying concept works, the more you can understand how and why particular tools and applications work the way they do. And speaking of which, if you are in a situation where you are doing something repetitive, or there's a particular need for a tool that doesn't exist currently, that if it existed would make your life a lot easier, if you are capable with a programming language, maybe you could create that tool yourself to make not only your life and job easier, but someone else's. So these are all different reasons why somebody would possibly want to learn a programming language. So what are we going to be covering in part one of this series? First, a general overview of programming languages, and then following up that with an overview of some common programming concepts. What is a programming language? We have 2 different definitions here. That one is a little more generic, one's a little more specific, but they both say the same thing effectively. First one, a programming language is a formalized language that provides an interface or set of rules and instructions that can be used to generate a desired result or output. Or in other words, a programming language is a set of commands a computer understands that tell it to do something. Now, what is that something? Well, that totally depended upon the program and the developer. So what is a programming language? In short, it is just that. It's a lexicon and a series of verbs and actions and how they can fit together that, when combined in a certain way, tell a program or an operating system or a piece of hardware to do something. Whether that is to produce a car, whether it is to display a web page, whatever the scenario is, that is what it's there for. So what are some common languages people can write in? As you can see here, this is a large grouping. I think there's 23 of them on the screen here, and this is just a small sampling of all the programming languages out there. There is well into over 100, possibly multiple hundreds of different programming languages out there. I personally have experience with, say, maybe half of them on the screen here. There's various different ones. You have assembly, you have stuff like C, a little more abstract ones like Scheme, or a little more out there like MATLAB or SQL. All of these are programming languages. What their purpose are kind of differs between them and what you're trying to solve with them. But there's tons and tons of programming languages out there. As a developer, you're probably going to pick one or a small group of these to learn and be building off of that. Personally, like I said, I have experience with a lot of them, but right now, most of my development is done in Python. While yes, I could program in C, C Sharp, Java, Perl, any number of other ones, Python is the one is my go-to language right now. And yeah, you'll do the same thing. You'll learn one, you'll move on to another, but you'll have the one that is your dominant one for a while. So, speaking of all those languages, why are there so many? I hinted at this a little bit, but there's different languages for different tasks. Let's say you're wanting to do some sort of GUI application that is platform independent. Well, you're probably going to be writing something in like Java. If you're, or say PHP, so it can be a web page, something like that. Let's say you're wanting to do something that is interacting with a database, or how to script up some actions in a database. We're probably going to be using SQL for that. And it's these different techniques that's going to be going on there. JavaScript has been building up recently here with a lot of interaction, or a lot of development. So there's lots of different techniques in there, and depending on what you're trying to gain out of it, if you're going to be doing a data science work, you're probably going to be working in like a R or something like that. So yeah, it's just what is the task you're wanting to solve or do. You're going to probably pick the language that's appropriate for that. Also, not all languages are created equal. While you could do effectively the same thing with assembly as you could C or C++, well, assembly, it's a lot lower level language, so you're going to have to understand stuff like jump registers and stack and heap and all that, and how they interact. Whereas if you're going into something that's a little more object-oriented like C++, you can create classes, you can create enums, you can have inheritance, which makes things a lot easier and a lot more human readable and understandable. But yeah, so depending on what you're wanting to do, that's going to help determine which language you're going to use. Are there different kinds of languages? Absolutely. You start out, well, there's a general two types of categories, two categorizations that people tend to use with programming languages. The one shown here is the 5-generation approach, where you start out with generation 1 is machine language, which is all zeros and ones, and those are interpreted directly on the CPU, the hardware, to perform an action. Beyond that, you have assembly language, which is a step back from that, where it can almost directly be translated into machine language, but it is a little more higher language. You can see stuff like move and jump and long jump and stuff like that. Read. You have some sort of commands in there that you can interact with a little bit. It's still very low level, but it's not zeros and ones. Coming on up from that, you have procedural languages, or generation 3 like C, C++, Java, Basic, Pascal. You have the other ones in there that are in red, which are generation 3, but they also share characteristics of generation 4. So you get a little more abstract the farther out you go until you hit stuff like intelligent languages at generation 5. And those are a particular type of programming out there that it's a programming language that you can use to create programs that aren't necessarily the solution to a problem, but they can produce the solution to a problem. You're getting into like rudimentary AI, stuff like that, learning languages. They can start to solve their own issues, stuff like that. So you have this kind of categorization. Then you have a more generic one where it's just 3 categories in there, with machine language or hardware language, where it's zeros and ones on the system. Compiled language, which is a language that you type up and it gets compiled down to machine code or machine language. Then you have interpreted, which is a programming language that you type up that gets interpreted by another program that it then translates into machine code or machine language to operate. So we're not going to get into this much more. That's just there for historical and reference information. As we're going through at least the intro to programming and possibly even beyond this, I'm going to be talking a lot about pseudocode. And what is pseudocode? Pseudocode is an informal, high-level language that programmers use to describe an algorithm or a computer program without tying it to any given programming language. The two blocks that you can see on the screen here do exactly the same thing. They're both pseudocode. The one on the left is just a little more verbose and written out in a sentence form almost. The one on the right is a little closer to what a programmer would ultimately write as part of the code. And they both do the same thing. They both define a function called add that says it takes two numbers and adds them up, stores the result. In the one on the right, it stores it as a value called sum, which is a variable, which we'll talk about in a moment. Then it returns that result back. And then outside of the functions is something we'll talk about as well in a moment. Outside of that, you have where it says it reads in two numbers or two values and stores them in variables A and B on the right there, as you can see. Then it prints out the result of calling that function with those values. So you can spell it out like this if you don't want to tie it to C or Java or Python or whatever. You can stay fairly abstracted out is what the pseudocode does for you. Yeah, you're going to see me use this a lot where I don't feel like writing exact code for whatever the algorithm is or whatever have you. I'll do this just so I get the point across. So let's jump into some programming concepts. As I said earlier, most languages have to account for some basic concepts in their lexicon or their language, and these are going to be stuff like I/O, file input output, screen input output, stuff like that, variables, commands and functions, then flow control. I'll talk about each of these in the upcoming slides here. Let's break I/O out into two parts, output and input. Output is when you tell program to put something to the screen, put it to the terminal. You're writing it out to a log file or a file or some other kind of log, or you're producing some sort of network communication. You're sending you produce an HTTP response or something like that. A perfect example of this is the classic hello world. Down here, as you can see, it's just print hello world. That's going to print it out to the screen or the terminal, depending on where this is being run from. Very typical there. And all languages have some form of an output concept. The corresponding portion to that is input. You can take input from the command line, the GUI, whatever this program is ran from. You can read it in from the terminal, as in you're piping a file in, something like that. Or you can tell it to open the file directly and read that in. You can receive input from some network communication. You're writing a server, something like that maybe. An example of this is we take a variable called str, and we're saying we want to set that equal to read line. We're reading a line from either the terminal, from the file, something like that. So here again, every language should have a way to take input from the user, from a file, something of that nature. I've mentioned variables a few times. What is a variable? If you're familiar with, like, let's say, algebra in mathematics, where you can say like ax or a plus x equals 5. Well, sorry, that's completely wrong. 5 plus x equals 10. Well, what is x? In this case, x is 5. But if you have multiple variables in there, they can be shifting. So let's say like, 5 plus x equals y. Well, depending on what you make x, y is going to change, and those can be fairly independent, and you can work around them. Where you don't know what those values are, you produce a placeholder. And that's exactly what a variable is. It's a placeholder. Why do we need them? Just as I said, when you're writing the program, you don't know what all the inputs are going to be or the values that are input. So when the user runs it and they provide an input, you take that and you store it as a variable, which then gets used later. If you're wanting to iterate through a list or produce a list, saying for iteration 1, 2, 3, 4, that incrementer is probably going to be a variable of some kind. There's different types of variables. There's different classifications. For here, I'm just defining it down to two basic types, a primitive and a constructed or a defined variable. A primitive is going to be something like an integer, a float, a boolean, a character, something that the language itself has hard-coded into it as to what it is. Some languages have stuff like lists, arrays, and strings as primitives. Not all do. Whereas a constructed or defined class or variable is something like a class, a struct, an enum, a string, something like that, depending on what it is. Don't worry about this too much right now. We'll be talking about constructed and defined variables types in the next series of slides here in part 2. Just wanted to bring them up right here so you're aware of the concept when I talk about it a little later. I'm combining commands and functions into one slide here. It's because they serve the same role in a program. They are what is used to tell a program what to do, how to do an action, something of that nature. If you're wanting to print something on the screen, that is a command. If you're wanting to read something from a file, that is a command. If you're wanting to, I don't know, let's say produce the sum of two values, or concatenate a string, or search through a string for a substring, all of these are commands. Commands or functions come in two basic varieties. As with variables, you have the built-ins, which are the ones hard-coded into the programming language. And then you have the user-defined ones. Well, a user can take the pre-existing functions and commands and recombine them in different sequences, define them, and we'll take a quick little look at a function later on, or a couple example code and pieces of code that use user-defined functions later on. But you can define functions any way you want. That's the glory of them, is they can be constructed out of other functions to do various acts that you want to repeat over and over, so you don't have to write it over and over every time. You have this one function that can be used there. So as you're writing code, sometimes you will need to branch, you need to check a condition, something like that. Well, there's these different things called control structures. They take the form of something like an if else, a while until, a for each. So let's step through some of these really quickly here. An if statement is just something as simple as if, and then in parentheses you put the condition, x is less than 10. If the statement is true, then you do the next line, which is indented in this case. So you're just incrementing x. You could do an if else, very similar. It starts out the same. If the condition x is less than 10, you increment it. Else, which means if that condition is not true, then you do something else. In this case, we're just decrementing that variable. You have the while statement, which says while x is less than 10, that's your condition, do the next line. And it's going to keep repeating until the while statement is true, or while the while statement becomes false. The condition, once it becomes false, then it exits out and moves on to the next section. A do until is just a rewritten while. You're saying do the following until this condition is met. Very similar to a while. Some languages do a do while or do until, some do a while. It just depends on the language. Then you have a for statement, which looks a little funky there, but it's the same basic concept as a while. You're saying for x, you're initializing the variable, x equals 0. Then you're doing the condition, x is less than 10. Then you're doing the increment, x equals x plus 1. And then for each one of those iterations through this loop, you're doing, in this case, do stuff on x. Some languages leave out parts of that, but the full spelled out version of it is here that most languages do take use of. Finally, you have the for each concept, which says for each x in a list of items. It might be a string of numbers, it might be a string of words, whatever the case is. For each iteration of that, do something. Okay, as we're going into examples and as we're getting into more and more code, you'll see me make use of all of these control structures a lot more. So let's go ahead and take a quick look at a couple of small programs just to get a feel for what I'm meaning by some of these concepts I was talking about. First one, the obligatory hello world. We've already shown that once. It's just to print hello world to the screen. Every language out there that I've ever worked in, somebody will write a hello world script for, or hello world program. it is just one of those things that is programmers do, and just to show how easy it is to print that out to the screen. Next up, let's say you wanted to write a program that does a summation. First of all, what is a summation? It's effectively this. This is the simplest version of it, but it gets the point across. You can say sum n, where n equals 0 and ends at n equals 5. What does that mean? It says take all numbers between 0 and 5 and add them up. So 0 plus 1 plus 2 plus 3 plus 4 plus 5, which does equal 15. Let's write a program that does that. Let's write a program that says, at the very bottom, you can say print summation 5. And that is what calls the function at the top. The function at the top is function summation. You take in a variable or a value called n. We're storing the 5 in there in this case. Then you declare sum equals 0. You always start at 0 in this case. We declare an iterator, I equals 1. So we're going to start at the first one going through. Here we're doing a while statement. While I is less than or equal to n, add up the value. So sum equals sum plus I. Then we increment I, so I equals I plus 1. And then when the while loop finishes, we return it. This code would do what that summation on the left does. So now let's go ahead and go into another example, very similar, factorial. Factorial is like summation, but instead of adding them up, you're multiplying them. So 5 factorial is, here you start at 1. You say 1 times 2 times 3 times 4 times 5, which equals 120. Code looks very similar. Again, at the bottom, we're doing the print factorial 5, which says to print out the result of that to the screen or terminal, what have you. If you jump back up to the top, we have the function factorial defined up there. That takes in a variable n as well. We're not doing a sum, so we're making a variable called prod for product. It's always great to have your variables mean something, so when you go back and look at it later, you can understand it. Our increment, well, product, we'll start that out as 1. Plus we start it out as 0, it's always going to be something multiplied by 0, which is always going to be 0. So we'll just start it out as 1 there. Same sort of loop, we're saying while I is less than n, product equals product times I, and then increment I equals I plus 1. When it finally finishes, you do the return. It's fairly straightforward, very similar to summation, just slightly different twist in there, things you have to think about as you're coding this up. Okay, I know we went through this very quickly. This is just as a refresher or as a glimpse into the world of programming is what I was looking for here. There's going to be 2 to 3 parts to this little intro series. Once we're done with that, then we'll jump into the Python programming, probably 2 to 3 parts to that as well. Then after that, we'll get into the Python for programmers, or Python for pen testers, where we're actually doing stuff with capturing data packets on the wire, scraping URLs, doing all kind of fun stuff with that. But what are we going to be looking at in part 2? Just go ahead and give you a heads up here. We'll probably be working with stuff like lists and arrays, hashes, and dictionaries. These are all different terms for sort of the same concept. It's used for storing lists or groupings of items into a variable or variables that you can easily access and query and pull information in and out of, or read and write to. Scope, local versus global. I'll just leave that there for right now. That is a very important topic that trips up a lot of people when they're first getting started in programming, and even people who've been doing it for a while. But we will be touching on that in part 2. Actually, that might actually get put out into another part all by itself because it's so important. And finally, classes and object-oriented programming. This is where I was saying we're talking about those defined or constructed variable types. Along with that, we're going to talk about inheritance very minimally in there just to get the concept across. So, thank you for sticking with me through this first part here of Intro to Programming. Hopefully it wasn't super boring and at least you followed along. If you have any questions, anything like that, please reach out to me in the comments below, something of that nature. So thank you very much and you have a great day.